Welcome to how to configure SUSE Manager and clients across your AWS organization. And our hope is that you leave this session with a high-level overview of how to overcome any AWS organization's challenges associated with a multi-root landscape. So let's dive right in. But first, a quick intro and a bit about SUSE and our partnership with AWS. I am Kevin Ayers, Partner Solutions Architect at SUSE on the AWS Alliance, and my cohort here is David Rocha, a Senior Partner Solutions Architect at AWS to the SUSE Alliance. And straight into the agenda, we'll chat about why SUSE and AWS, why SUSE Manager makes sense and what it does for you, and finally, how to overcome some of the unique network challenges and security domain challenges present within the AWS organization's logical construct. So now, assuming you're running compute on EC2 and are faced with deployment, lifecycle management, CVE mitigation, configuration management, and so on, all of the typical enterprise IT concerns, we'll discuss SUSE Manager as the solution. It's not new, it is mature, and it's environmentally agnostic. More on that in a minute. So before we get started here, we just celebrated a great milestone with 10 years of partnership between the two companies. And while that's a big milestone, there have certainly been many others. SUSE is an APN Partner of the Year for 2020. If we look in detail at this, we have many years of collaboration, multiple certifications and awards, and ever-increasing momentum as partners. We're an advanced tier APN tech partner with container competency. We're AWS Outpost ready and part of the public sector partner program. SUSE is a preferred partner for SAP on AWS with a clear market share lead. And we have a seamless and very simplified support model with SUSE trained engineers at AWS within the escalation path. So why SUSE Manager? Well, absolute best-in-class enterprise IT systems management. You buy it as a BYOL or BYOS license. You own it. You use it on-prem, on EC2, etc. There's no limits. You can manage your environment from cloud to core to edge-of-edge devices with a myriad of supported operating systems. Amazon Linux works currently, and it's officially supported with the SUMA 4.2 release, which is coming out this summer. And we partner with Amazon on their Amazon Linux development roadmap. So why SUSE Manager on the cloud? Well, everything's moving there, and particularly to AWS. The same systems management and orchestration requirements exist. Security can be even, a larger concern on the cloud in some cases. Things like desired state control, again, CVE mitigation, are more critical than ever. You can manage your entire hybrid on-premise multi-cloud environment from a single pane of glass on SUMA on EC2. And as with any systems management tool, in many cases, the outbound I/O costs could be significant. So carefully consider how you design the overall SUMA architecture, including possibly using additional SUMA servers or even SUMA proxy. So what do we actually deliver? Well, you can launch a BYOS instance from the community marketplace by simply searching for SUSE Manager, and then grab a subscription from your SUSE sales rep. You can then mass onboard your pay-as-you-go and BYOS instances to immediately have observability across your entire managed landscape. And on that note, we have a supported solution for monitoring your instances using Prometheus and Grafana, as well as pre-built dashboards, included as part of SUMA monitoring. As I said, the AMIs are in the community marketplace. It's easy to connect your pay-as-you-go on-demand instances using our mass onboarding functionality. Obviously, because you own the sub, you can run it on-premise to manage your various clouds from there. So if you run SAP, which is a very common use case, and particularly with SUSE on AWS, the lifecycle management CALs are already included in your SAP update channel. Monitoring CALs are also being added to this channel. So, go ahead and shoot us an email to engage sales or get other guidance. And caveats. Okay, what's the recipe for success? Well, again, you need a subscription if you don't have one, and you can use it anywhere. There are a number of standard TCP ports required for your network ACLs or security groups, including HTTP, SSH, SALT. It's not that scary, though. Root accounts represent the security domain that we have to work across, and David will discuss this more in a minute. For very large organizations or in situations where you want to control caching and I/O, SUMA proxy is a good idea, a good thing to consider, particularly if you're trying to work around those outbound I/O costs. SAP, if you're using SAP, please get SUMA. You get a great value there in the SAP channel when it comes to features you'd otherwise pay for. If you're not doing lifecycle management, CVE mitigation, config management, among other things, then you have trouble ahead, and you can avoid this. We do integrate with Ansible, but frankly, once you taste salt, you won't go back. There you go. And most of the SAP escalations that we see could have been avoided with proper configuration. So, particularly around Pacemaker and the SUSE HA module, SUMA can definitely help there. Okay, a scary picture for you. There are a couple of TCP ports you want. As I said, this is basically SSL and SALT. And, allowing any port from any location is a bad idea. The configuration around SUMA is not that complex. So, part of the SUSE legacy is that we spend money on engineering and support rather than advertising vaporware. So we actually have application maps and escalation engineers who understand them, and excellent best practice docs for every product, including SUMA. You can see that aside from SSL, there are a few TCP ports here for your NACLs and security groups. It's pretty straightforward, but I did want to give you a scary picture. So now David Rocha over at AWS will dive into an approach for implementing SUMA within an organization with multiple root accounts and geos to ensure that it can be implemented across these security domains without the typical hiccups. This is a broad stroke, but tested concept design. And if you want to get deeper into the weeds on implementation, please reach out to us at SUSE or AWS. We can bring implementation architects and engineers to bear with very little lead time for new or existing initiatives. Please go ahead, David.
Thanks, Kevin. Now for this section, I'll explain what an AWS organization is and the VPC sharing feature that is available when using an AWS organization. I'll also cover how SUSE Manager is able to connect to Amazon EC2 instances across your AWS organization in a VPC sharing scenario. An AWS organization is an account management service that lets you consolidate multiple accounts into an account structure that you create and centrally manage. As an administrator, you can create new accounts and invite existing accounts to join your AWS organization. This can be done either through the AWS console or using APIs that allow your business to build workflows for account requests. AWS organizations also provide consolidated billing capabilities that enable you to better meet the budgetary, security, and compliance needs of your AWS environment. Now, before we discuss VPC sharing and how it enables you to connect your Linux landscape with SUSE Manager, let's take a look at what an organization looks like in the simplified version. At the top, you have the organizational root account. This is the parent account for all the member accounts of your organization. We have organizational units, which allow you to group accounts or other organizational units together. Now, the organizational units can represent departments within a business, such as finance or marketing. It really depends on how you want to organize your accounts. A member account is an account that you created or invite into your AWS organization. It is not a special AWS account or service. Additionally, a member account can be removed from the AWS organization and become an independent account. So let's take a look at VPC sharing. By using an AWS organization, you're enabling a feature called VPC sharing with other AWS member accounts. The way VPC sharing works is on the organizational root account or a member account. You can set up a VPC and subnets, and you can share those subnets with other member accounts. So if we think about your infrastructure team, your network engineers can own a member account that shares one or many VPCs. The feature allows your network security team to centrally manage your NACLs, VPNs, or even your direct connect connections. And your application developers do not need to worry about the network management piece. Additionally, using a shared VPC does not change the process or limit the capability to launch Amazon EC2 instances. All you need is a shared VPC subnet. And in fact, this is also true when launching an RDS database or any other AWS services inside of a shared VPC. And the instances that are launched in the shared VPC are managed the same way that you manage any other instances. I do want to point out, we do not recommend creating a single large VPC and placing everything in it. It really defeats the purpose of segmenting production, testing, and development network traffic. Now, shared VPCs align well with customers who use SUSE Manager. The SUSE Manager team can leverage a shared production VPC and take advantage of a centrally managed network that spans across member accounts. Now, there are a few key points about sharing a subnet that I do need to cover. First, the owner is the account that created the VPC and shared it with the other members of the AWS organization. They are responsible for setting up all the VPC level resources, such as subnets, routing, and NACLs. Participants are responsible for the creation, management, and deletion of their resources like Amazon EC2 instances or Amazon RDS. Also, member accounts that are participating in the shared VPC cannot view or modify resources run by another member account. So by participating in a shared VPC, you're not opening or enabling the other accounts to view your launched instances. So Resource Access Manager is a service in the AWS console. It's the service that you use to set up the VPC share with member accounts in your AWS organization. And when using VPC sharing, there are times where you want a set of instances from different member accounts on the same availability zone. The reason is you can save money by taking advantage of the free intra-availability zone data transfer across accounts. Additionally, there may be times you do not want certain instances from a different member account on the same availability zone as your running instances. Customers will often request this based off of fault tolerance purposes. In Resource Access Manager, you can determine the location of your resources relative to other AWS accounts by looking at the AZID. The AZID is a unique and consistent identifier for an availability zone across all of your accounts. And next, I do want to review a few key points regarding security groups and NACLs that you need to keep in mind for VPC sharing. So you can reference security groups from accounts that have access to the shared VPC. For example, you can add a security group rule to a Linux instance in your finance account that allows inbound traffic from the security group associated to your SUSE Manager instance. The SUSE Manager instance is running in your infrastructure account, and this allows necessary ports for a SUSE Manager connection to your finance Linux instance. What you can't do is try to launch an instance from your finance account using a security group that belongs to, let's say, your marketing account, even if you are both using a shared VPC. Also, the account that created the VPC share has central control over the NACLs. The participating accounts do not have access to create or edit those NACLs. So let's look at a diagram that shows connections before VPC sharing has been set up. You have to manage each of the connections between each of the accounts. This can be done across the internet using a NAT gateway service or VPC peering. Regardless, it is not something that is easily managed, especially if your business has a large number of accounts. Plus, not only do you have a decentralized configuration and management scenario, you also have effectively decentralized responsibility from your networking team. Looking at the diagram, you would have to manage each of the connections to each of the AWS accounts so that SUSE Manager can manage your Linux landscape. Now let's look at after you have set up VPC sharing. You have a VPC shared by the infrastructure account. It's a production VPC that is running for various member accounts in your organization. You have your SUSE Manager instance in the same production VPC as your other Linux instances from your participating accounts. And since you're on the same VPC, you're not having to set up any external connections across the accounts to allow SUSE Manager to connect to your Linux instances. In this setup, you maintain a centralized management of the network resources using a shared VPC. And you can easily manage the Amazon EC2 instances on the shared VPC without setting up any additional networking connections. So what do we do with the other AWS accounts that are not part of the shared VPC? So in order to simplify the diagram, I removed the accounts that were using the production shared VPC that was created by the infrastructure account. SUSE Manager is still in the infrastructure production account, and this diagram shows the rest of the accounts from the original diagram that did not participate in the shared VPC. The other accounts still have EC2 instances that need to be able to connect to SUSE Manager. So instances can connect to SUSE Manager through the internet using TCP ports 8443 and SALT ports 4505 and 4506. The traffic between the instances is secured across 443, 4505, and 4506. Now, SUSE Manager can be in the public subnet and have an elastic IP or EIP address to connect to the other accounts. And each of the accounts will need an internet gateway, which enables internet traffic. It will require the correct routing table entry traffic to the internet gateway. And of course, you need the proper NACLs and security group entries required for the SUSE Manager and client connection. In the case of your instances being on a private subnet, you can use a NAT gateway to enable instances in a private subnet to connect to the SUSE Manager instance. And it does prevent the internet from initiating an external connection to those instances. So you're not introducing any security risks. So now that everything has been set up, the work can really begin. So for more setup or use regarding SUSE Manager, please check out the following links or view TUT 1082 for more information. Thank you for joining session Best Practice 1106.